Okay, we are going to evaluate the limit as x approaching 1 of x over x minus 1 minus 1 over ln x. And usually when we have fractions like this, we should just combine them and then see what we can do. So let me erase this right here, because for the first fraction, we will have to multiply the top and bottom by ln x to get the common denominator. And then for the second one, we'll multiply this by that, which is x minus 1 and also x minus 1. Okay. And then let's see what we get from here. This is going to be the limit as x approaching 1, and then on the bottom we have this for the denominator, so that's x minus 1 times ln x. And then for the top, first we have this, which is just x ln x, and then minus 1 times that. So be sure we take the negative and then distribute into the parentheses. So we get negative x. Negative, just be really careful. We have a positive and then we have the 1. And now, just real quick, put 1 into all the x's. On the top, because ln1 is 0, so this is 0, and then put 1 in here. Negative 1 plus 1 is 0. And then on the bottom, well, when we put 1 in here, well, here, it's just 0. So we have a 0 over 0 situation. That's good, because we can use L'Hopital's rule. So always make sure that we can use L'Hopital's rule either with the 0 over 0 case or the infinity over infinity case. So here we go. Differentiate the top and then differentiate the bottom. And still, let's write down the limit as x approaching 1. On the top, we will have to use the product rule because you see this is x times ln x. Keep the first function times the derivative of the second. Derivative of ln x is 1 over x, and then we add the second function times the derivative of the first, which is just going to be 1, and then minus the derivative of x is just 1, and then the derivative plus 1 is just 0. On the bottom, we also have to use the product rule. Yeah, so let's go ahead and do it. Let's keep this right here as the first function, so parentheses x minus 1 times the derivative of the second, which is 1 over x, and then we add the second function, that's ln x, and multiply by the derivative of the first, which is just 1. So that's what we have. And let's see if there's anything that we can cancel out. Yeah, because this and that is just equal to 1, right? And then 1 minus 1, that's good, that's just 0, that's good. And then on the bottom, we can distribute. Alright, so that will be 1 minus 1 over x and ln x. But let me tell you, we'll still end up with 0 over 0. Let me write it down better for you guys right here. Limit as x approaching 1. On the top though, because 1 minus 1 is 0, so we just have the ln x. On the bottom, this times that is 1. This times that, I'll just keep it as negative. Maybe let's write it as x to a negative 1 power. So that we can take the derivative easily, and then plus ln x. When we're plugging 1 into all the x's, we get 0 over 0 again. So let's go ahead and just differentiate the top and then differentiate the bottom. And again, this right here works because we have the 0 over 0 case. That's why we can use L'Hopital's rule. So with that said, we have the limit as x approaching 1. On the top gives us 1 over x. On the bottom, this is going to be 0, and this right here, put the power to the front and then minus 1, so we get positive, and then we have x to the negative 2. And then this right here is just 1 over x. Alright? So now if you take a look right here, we can simplify this, or you can just plug in 1 into all the x's, up to you. Just plugging 1 into all the x's, it's just 1 anyway, right? So 1 over 1 over 1 to the negative 2 plus 1 over 1. On the top is 1. On the bottom is 1 plus 1. So ladies and gentlemen, the answer is just 1/2. And that's it for that limit, and then we are done.